Hi guys, I'm James. A couple things that I should tell you about me. I like golf, hockey, and Rubik's Cubes. If I didn't meet you already this conference, I hope I can meet you today. I want to say thank you to Bill Gosper because he gave me this problem. So the problem is on an annular basis, you get a gold disc of radius 1. Punch out a hole in the middle with radius R to give to charity. The taxman cuts off as much as he can, taking a tangent line to the charity circle, as the diagram shows. And what radius do you give to charity to maximize your take-home? So I will solve this problem 2 different ways, and if you can find a different way, please come up to me after and tell me. So the answer I get is R equals the square root of 1 over pi squared plus 1. And the first way I solve this is I know that I will maximize my take-home when the radius is, or when the circumference of the charity hole is equal to the length of the tax cord, because when you increase R by dr, you lose 2 pi r dr, but you gain the length of the tax cord times dr. So using the Pythagorean theorem, we figure out that half the tax cord is the square root of 1 minus r squared. So the whole tax cord is 2 times that. And now you solve the algebra for that, and you do get r equals the square root of 1 over pi squared plus 1. Graphing this function shows this graph where the line crosses the x-axis at roughly 0.3, which is exactly where the square root of 1 over pi squared plus 1 is. If you don't buy it, I can show you how to calculate it the harder way. So the harder way to do it is to calculate the area of the take-home, and that equals the area of the disk minus the area of the charity minus the area of the tax. So you know that the radius of the gold disc is 1, so the area of the disk is pi, and the radius of the charity hole is r, so the area is pi r squared. But how do you calculate the area of the tax segment? So I did this. I found the area of this sector, and then I subtracted the area of this triangle. So if you call this angle theta, then, and there are 2 pi radians in a circle, you have to find angle theta. So cosine of theta is r. So arc cosine of r is theta. And now you just have to subtract the area of the triangle, which is r times the square root of 1 minus r squared. So now you have the area of the tax segment right here. So now you know the area of the take-home is pi minus pi r squared minus arc cosine r minus r times the square root of 1 minus r squared. So graphing this function shows this, and this function peaks out at the exact same place that the other graph hit the x-axis. And there's another way of showing this. It's if you graph the derivative of the function I just calculated, then you can compare it with the other graph, and they're the same graph. So another problem to consider is, suppose there is a more charitable-oriented benefactor who wants to support his favorite charity up to the point where his X dollar gift costs him no more than 0.2 X dollars in after-tax income. What radius should he give? And I want to say thanks to Elwin Burleycamp for this variation. My gift is going to be, I'm going to give you a sticker with this problem, and my better gift, or my bigger gift, is I made a website with videos on how I solved some of my favorite problems and played games with some of my favorite people. So please go to mathwithjames.com. Thanks.